Yann Robillot-Dupont for another perspective.
Thank you. It's good to be back in Oxford. I used to work in across the road on cosmology, ironically on how the universe is cooling down, but I couldn't find a solution to climate change. So instead, I'll tell you something about the equitably determined contributions to reach the Paris Agreement goals, and in particular, the 1.5 degree perspective of our results. So the starting point of our study is to identify the cost-optimal emission scenarios from integrated assessment models that are consistent with the Paris Agreement. So here you can see the cost-optimal scenarios that have a likely chance to stay below 2 degrees. And we've drawn the distinctions between those having emissions peaking by 2020 and those peaking in 2030, as the Article 4 of the Paris Agreement calls for a peaking of emissions as soon as possible. As you may know, there are very few emission scenarios in the IPCC-R5 database that are consistent with the 1.5 degree goal. So instead, we've taken those who were, and we've added scenarios from a previous study that offer a 50% chance to return to 1.5 degrees. So there is an overshoot of the 1.5 degree limit over the century. If we look at the average of these emissions ranges and compare them to the aggregated INDC, we can see that the aggregated INDCs are way higher than those ranges. And we find that the average of the 2 degree scenarios is around 40 gigaton of CO2, which is exactly in line with the Paris decision goal. And the average of the 1.5 degree scenarios is at 32.6 gigaton of CO2. So there is a great mitigation gap that was also acknowledged in the Paris decision. The question from then on is how to allocate the emissions from these cost-optimal scenarios across countries in an equitable manner. So let's talk about equity. So we've selected, we've taken the 5 categories of equity that were highlighted in the IPCC-R5 and modeled allocation framework to distribute the emissions of the IM scenarios that I showed before according to each of these 5 equity categories. So the first one is capability. So basically, countries get an inversely proportional share of the global emissions compared to their GDP per capita. So the richest nations get lower allowances. The equal per capita is pretty straightforward. Then we have the greenhouse development rights that we heard about a few times during this conference. It includes notion of historical responsibility, capability, and need. We have the equal cumulative per capita that encompasses historical emissions, historical responsibility, and finally the constant emission ratio that is really a grandfathering approach. So all countries decrease their emissions at the same rate. So if we look at the emission pathways for 4 major emitters towards 1.5 degrees, so here we've taken the average of the 1.5 degree scenarios, we can see that the INDCs of most of these countries are not sufficient to meet the 1.5 degree goal. That obviously doesn't come up as a surprise. India and the US are potentially in line with one of the 5 equity approach, keeping in mind that the USA are in line with a grandfathering approach and that the fairness of that approach is arguable. If we now compare with the ranges of emissions allocated under the 2 degree goal, we find that the USA, the EU, and India are now in line with more equity approaches. But overall, when we look over all countries, we find that developed countries have relatively unambitious INDCs in light of that modeling, and that developing countries actually rank better in terms of equity ranking. Now, we'll focus from now on the difference between aiming at 2 degrees and 1.5 degrees. So here, this graph looks at the emissions towards both these temperature goals in 2030. So on the x-axis, you can see the mitigation averaged over the 5 equity approaches necessary to go for 2 degrees, and on the y-axis for 1.5 degrees. So you can see the offset compared to the diagonal is the additional effort that a country should produce to meet 1.5 degrees compared to 2 degrees. In this case, we can see that China should reduce its emissions in 2030 by an additional 21 percentage points. If we look at our countries, we can see that developed countries should produce an additional effort of about 20 points to reach the 1.5 degree goals compared to the 2 degree. Developing countries have a much higher additional effort to provide. We should keep in mind that all countries in the top right quadrant can still have higher emissions in 2030 than in 2010. If we look at more actionable targets, we can look at the time for peaking emissions here. We can see that developed countries should peak emissions as soon as possible under both temperature goals. The other countries, the developing countries for most, actually can peak emissions in the future, but should peak emissions about 10 years earlier when aiming at 1.5 degrees compared to 2 degrees. If we look at the magnitude of that emission peaking, we find that emissions should peak at levels 20 to 40% lower when aiming at 1.5 degrees. And finally, if we look at the timing for net zero emissions, we find that developed countries should peak emissions 10 years earlier when going from 1.5 degrees, so around 2060, and developing countries should phase out emissions only 5 years earlier towards 1.5 degrees, so around 2080. So we have derived all these results for the different equity approaches. I've presented the average to get a clearer picture. We also derived the emissions allocations for all countries, and this is currently under review with Nature Climate Change, so we'll try to make all the data publicly available in the supplementary information. Thank you.